Troesch homework number 44. Take a look at it if you want. And now let's get into it. So we are going to be doing the even problems. So starting from number 30. So it says, solve the nonlinear inequality, express the solution using interval notation, and graph the solution set. So what it means by solve the nonlinear inequality is, for example, if I take the question number 30, and let's say if I plug in 6 for x, well, what do I get? Well, 6 minus 5 is 1, and 6 plus 4 is 10. 10 times 1 is 10, and 10 is greater than 0. So what I'm trying to do is I'm trying to find numbers like 6 where it works, right? It works for this nonlinear equality. I'm trying to find numbers that make this inequality true. So yeah, that's basically what the problem is asking us to do. And we're supposed to express the solution using interval notation, and we're supposed to graph the solution set, aka one-dimensional number line. We have x minus 5 times x plus 4 is greater than equal to 0. So first step you want to do in these questions is you want to move everything to one side so that the other side is equal to 0. However, that's already done for us, so we don't have to worry about that. Now, what values of x make this inequality equal to 0? So what do I have to plug into the x to make this equal to 0? And I'm going to put these on the number line. Well, when x is equal to positive 5, 5 minus 5 is 0, right? 5 minus 5 is 0, and then 0 times anything is 0. So if I plug in 5 here, it's going to equal to 0. And if I plug in negative 4 here, negative 4 plus 4 is 0. 0 times anything is 0. So negative 4 makes this inequality equal to 0. Now, because this is a greater than and equal to sign, if it has an equal to sign, what you want to do is you want to draw closed circles on top of the numbers. The closed circle just indicates that this number is going to be part of our solution when we're writing this in interval notation. So we'll get to that later. Now you notice how these two numbers, right, when I graph them on my number line, it splits up the number line into 3 sections. So let's test out a number from each section to see if it makes this inequality true. So yep. Okay, so let's say I pick a number greater than 5. Right, this section is from 5 to infinity. So let's say I pick the number 6. If I plug 6 into x, 6 minus 5 is 1. 6 plus 4 is 10. 10 times 1 is 10, and 10 is greater than 0. Which means that this part of our number line is part of the solution. Alright, so the strategy I'm basically doing is I'm going to test a number, right? I'm going to pick a number from this section of my number line. I'm going to plug it into x, and if it works for the inequality, well, if one of the number works in this range, all of the numbers work in this range. And if it doesn't work, well, all of the numbers do not work. Alright, so it's like either it works or it doesn't. Alright, let's say I pick a number from negative 4 to 5. That should be 0, right? 0 is part of this range. So I plug in 0 for x. I get negative 5 times positive 4, which is negative 20. And negative 20 is not greater than 0, right? Which means that numbers in between this range are not part of our solution. Finally, let's plug in a number that's less than negative 4. So I plug in negative 5. Negative 5 minus 5 is negative 10. And negative 5 plus 4 is negative 1. Negative 10 times negative 1 creates a positive 10, and 10 is greater than 0, which means that numbers in this range work. In interval notation, the way you write this out is, well, it looks like that any x value that's greater than or equal to 5, well, that works. And any x value that's less than or equal to negative 4, this also works. And that's going to be our solution. All right, this open circle just indicates that, in this case, if I'm talking about this part of our number line, that means that this is less than and equal to, less than or equal to, sorry. And if I'm talking about this part of the number line, this open circle, and if I'm talking about this part of our number line, well, this closed circle, this shaded in circle just means that it's greater than or equal to, right? If this circle was not shaded in and the circle looked something like this, that means it's only greater than. However, if it has this shaded part, you have to include the equals to at the bottom. On to problem 32. X times 2 minus 3x is less than or equal to 0. So once again, first step, what you want to do in these problems is you want to move everything to one side so that the other side is equal to 0. However, this problem, it's already like that. Remember, what you want to do is you want to find out x values that make this inequality equal to 0. So what x values make this inequality equal to 0? Well, you'll notice how if you plug in the 0 in for x, well, the 0 times whatever this is, well, it's going to equal to 0. So 0 is one of our points we need to highlight on our number line. And what other value makes this equal to 0? Well, if you want this whole thing to equal to 0, then the thing inside the parentheses has to be equal to 0, right? And this is just the 0 product property. So we set 2 minus 3x equal to 0. And then after that, if we solve for x, 3x equals 2, and then x equals 2/3. So 2/3 is also going to be our number line. All right. Now, because this is a less than or equal to sign, as this equal to thing in the bottom, which means that we are going to use shaded in circles on top of our number line. Notice how our thing is divided into 3 sections, right? Our number line is divided into 3 sections. So let's test the number from each section to see if it makes this inequality true. So what are numbers that are greater than 2/3? Well, 1. 1 is greater than 2/3. So let's try this number out. If I plug in 1 for x, I get 1 times 2 minus 3. So 1 times 2 minus 3 is -1. And I get 1 times -1. So 1 times -1, which is equal to -1. And -1 is less than 0, which means that this part of our number line is included in our solution set. Let's test out numbers from 0 to 2/3. So let's test out 1/3, right? This is in between those two numbers. If I plug in 1/3 in for x, I get 1/3 times 2 minus 3 times 1/3. 3 times 1/3 is just 1. So 2 minus 1 less than or equal to 0. 2 minus 1 is 1. 1 times 1/3 is just 1/3. And 1/3 is not less than or equal to 0, meaning that numbers in this range do not work, right? Finally, let's test out numbers that are less than 0. If I plug in -1 in for x, I get -1 times 2 minus 3 times -1, which is just 2 plus 3, because negative makes positive. 2 plus 3 is 5. 5 times -1 is -5. -5 is, yes, it's less than, or it's less than 0, which means that it is part of our solution. So yeah, our answer is that anything that's less than or equal to 0, well, that's going to be part of our solution, right? It's shown in this number line. And anything that's greater than or equal to 2/3, well, yeah, we also highlighted that in our number line. That's it. Now let's move on to number 34. So we have x squared plus 5x plus 6 is greater than 0. X plus 6 is greater than 0. Now, first step, once again, you want to move everything to one side so that the other side is equal to 0. Once again, the problems are nice enough so that we don't have to do that, right? Once the other side's already equal to 0. So we ignore this step. Now, the problem is, now, right, we can't do our second step normally. Normally, we would have to, we create our number line, and then we find x values that make this inequality equal to 0. However, from this thing right over here, it's not really clear what x values make this equal to 0, which is why we need a factor. And I'm assuming y'all know how to factor already. Sorry if y'all don't. So yeah, x plus 3 times x plus 2 are the factors of this. Two numbers that multiply out to be 6, and they add up to be the coefficient of this x term, which is 5, right? Two numbers that multiply to be 6 and add up to be 5. So now it's pretty clear what x values make this equal to 0, right? If I plug in -3, well, this is going to be equal to 0, right? And if I plug in -2 in for x, this is also going to be equal to 0. So -3 and -2 are points, critical points. And because this does not have the, right now we only have the greater than sign, but because this does not have the greater than or equal to, does not have the equal to at the bottom, which means that we have to not fill in our circle, right? If it included the equal to sign, we would have to shade in the circle, but because it does not include the equal sign, well, we just have this open circles. Once again, same procedure. We test out one number from every region because our number line is divided into 3 sections, and let's see if it's true or not. What are numbers greater than -2? Let's test out 0. So if I plug in 0 for x, I get 3 times 2, which is 6, and 6 is greater than 0. So this part of our number line works. If I plug in a number in between -3 and -2, let's say -2.5. Well, we know that if I plug in -2.5 here, this is going to be positive, right? I'm going to get 0.5. And if I plug in -2.5 in here, right, I plug it into the x's, -2.5 plus 2 is -0.5. And this positive number times this negative number is going to give me a negative number. And negative numbers are obviously not greater than 0, right? They're less than 0. So this makes the inequality false, which means that numbers in between this range are not part of our solution. Finally, let's look at numbers that are less than -3. Let's say -4. Plug in -4 here. -4 plus 3 is a negative number. And if I plug in -4 here, -4 plus 2 is also a negative number. Negative makes a positive. And positive numbers are greater than 0, which means that things over here, they also work. In interval notation, I would just say that any number that's greater than -2 works, and any number that's below -3 works. Now let's do number 36. So we have x squared is less than x plus 2. First step, you want to move everything to one side so that the other side is equal to 0. So to make the right-hand side equal to 0, I'm just going to subtract x. I'm going to subtract 2 from both sides. This cancels out, so I get x squared minus x minus 2 is less than 0. And now, it's not really clear what numbers I can put in for x that make this equal to 0, which means that I have to factor. And when I factor this, I get x minus 2, and x plus 1, right? Two numbers that multiply out to be -2, and -2 plus 1 gives me -1, which is the coefficient of the x term. So now it's pretty clear what numbers make this equal to 0. If I plug in positive 2 here, well, this is going to equal to 0, and if I plug in -1 here, it's also going to be equal to 0. Once again, divides our number line into 3 sections, test out a number from each section, you know the drill. So let's say a number that's greater than 2. Let's say it's 3. And also because, I forgot this step, but also because our inequality does not have an equal to sign, right? It's only less than, not at less than or equal to. That means that we are going to have open circles, right? We're not going to shade in the circles unless it has the equal to sign at the bottom. So let's test out a number that's greater than 2. Number that's greater than 2, 3. So if I plug in 3 in here, I get 1 times 4, which is not less than 0, obviously. So this does not work. If I plug in a number in between -1 and 2, let's say I plug in 0. -2 times 1 is less than 0. Yes. So this works. Finally, let's test out a number that's less than -1. So -2. So -2 minus 2 is -4. And -2 plus 1 is -1. -4 times -1 is positive 4. And positive 4 is not less than 0. Which means that this part of our number line does not work as our solution. So in interval notation, well, it looks like that x values that are in between -1 and 2, aka x values that are greater than -1 and less than 2, well, it looks like this is our answer, right? X values are greater than -1 and less than 2 is our answer. Let's do number 38. So 5x squared plus 3x greater than or equal to 3x squared plus 2. First off, we want to get everything to one side. So let's just subtract 3x squared and 2 from both sides. So we get 5x squared plus 3x minus 3x squared minus 2. And once again, this cancels out, greater than or equal to 0. So we got one side, we got the other side equal to 0. We can do a little bit of simplifying. This 5x squared and this 3x squared, they cancel out to make it 2x squared, right? 5x squared cancel out to make it 2x squared. And we have 2x squared plus 3x minus 2 is greater than or equal to 0. So now it's pretty unclear what x values to put in that makes this equal to 0, which means we have to factor. However, we can't just do trinomial factoring, right? The factoring we did before, because the coefficient of our x squared term is greater than 1, which means we have to factor by grouping. In order to factor by grouping, you multiply the coefficient of the x squared term by the constant, which is the term without an x. And 2 times negative 2 is negative 4. And next, you want to take a look at your coefficient of the x term. So if you have an x term, well, the number in front of the x, well, that's the number that you're going to be looking at. So we have positive 3 and negative 4. And you want to find two numbers that multiply to be negative 4 and add up to be positive 3. And the correct combination, well, that's going to be positive 4 and negative 1. Right? Negative 1 times 4 is negative 4. And 4 plus negative 1 is 3. So those are two numbers that do that. And right now, I am going to break up this middle term. So you notice how from the numbers I got from doing the strategy I did, right? Multiplying this by this and then finding two numbers that blah, 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 right? You notice how now I broke up my middle term into two x terms that have the coefficient of exactly what I was just talking about. Notice how the equation inequality is still equal. I just broken it down into another form. So we can factor a 2x from this part, right? 2x squared and 4x share a common factor of 2x. If I take a 2x out of 2x squared, I'm just going to be left with x. And if I take a 2x out of 4x, I'm just going to be left with plus 2. Positive 2. Now we can group these two together. If I have a negative x and a negative 2, I can take out a negative 1. Doing so, if I take out a negative 1 from negative x, I'm just going to be left with x. If I take out a negative 1 from negative 2, I'm just going to be left with positive 2. And now, once again, we can factor by grouping. So, but finish the factoring by grouping. We take one of the copies, right? Because these two numbers inside the parentheses are equal. Just take one of the copies, slap them together, and then take the rest that are not inside the parentheses, which is this 2x and this negative 1. We slap them together, and that's how you factor by grouping. So when we do all of that, we get x plus 2 times 2x minus 1, and don't forget that this is greater than 0. Greater than or equal to, sorry. Greater than or equal to. All right. So now, what numbers make this inequality equal to 0? Well, if I plug in negative 2 here, that's going to make this equal to 0. And now, in order for this whole thing to be 0, I can have 2x minus 1 equal to 0 due to the zero product property. Add 1 to both sides, divide by 2, and I get x is equal to 1/2. So 1/2 makes this thing equal to 0. Because this has a greater than or equal to sign, this equal to sign at the bottom, I'm going to have a shaded in circle. Open. Not an open circle, closed circle. All right, 3 sections, you know the drill. So let's say if I plug in positive 1, which is part of this region. Well, if I plug in 1 here, I get 1 plus 2 is 3, 2 times 1 minus 1 is 2 minus 1, which is just 1. So if I plug in 1 in for x, I get 3 times 1, which is just 3. And 3 is greater than 0. So this part of my number line works. Let's say I plug in a number in between -2 and 1/2. Let's say I plug in 0. I get 2 times -1, which is -2, and -2 is not greater than or equal to 0, which means this part of our number line does not work. And if I plug in numbers that are less than -2, let's say I plug in -3, -3 plus 2 is -1, 2 times -3 is -6, minus 1 is -7, -1 times -7 is 7, and 7 is greater than 0, meaning that this part of our number line works. So any x value that's less than or equal to -2 and greater than or equal to 1/2, they work as our solutions. Next problem, x squared plus 2x is greater than 3. Want to move everything to one side first, so let's subtract 3 from both sides. We get that x squared plus 2x minus 3 is greater than 0. Now we can factor this because it's pretty unclear what x values I can put in to make this equal to 0. And my coefficient of my x term is 1, which means I can do trinomial factoring. Because it looks like, well, it looks like two numbers that multiply up to be -3 and add up to be +2 is +3 and -1, right? -1 and -1 and 3 multiply out to be -3 and add up to be 2. And obviously this is still greater than 0. Do our number line thing. It looks like -3 makes this equal to 0 and +1 makes this equal to 0. Whoops. Alright. And because it doesn't have the greater than or equal to sign at the bottom, we do open circles. Once again, plug in number from each section and see if it works. So let's say if I plug in 2, number that's greater than 1. Well, 2 plus 3 is 5. We have 5 times 1, and 5 is greater than 0, which means numbers in this range work. What about numbers in between -3 and 1? If I plug in 0 in for x, I get 3 times -1, which is -3, and -3 is not greater than 0, which means numbers in this range do not work. What about numbers that are less than -3? If I plug in -5, let's just say, -5 plus 3 is -2, -5 minus 1 is -6, -2 times -6 is +16, which is greater than 0. Therefore, numbers in this range also work. Looks like numbers that are greater than 1 and numbers that are less than -3 work. So our answer is x values that are greater than 1 or x values that are less than -3. It's an or statement because it's not an and statement. You would not say the answer is x is greater than 1 and x is less than -3. Because how can a number be greater than 1 and less than -3 at the same time? So whenever on the number line, it looks like these two things do not touch, right? This middle thing, right? You have a space in the middle. These two parts do not touch, which means that this is going to be an or statement. It's either this part or going this path. All right, problem 42, x squared greater than equal to 9. So we have first step, once again, y'all know the drill already. So I'm going to go a little bit faster now. Move everything to one side. So we subtract 9. We get x squared minus 9. X squared minus 9 is greater than or equal to 0. And factoring this by a difference of perfect squares, hopefully you know this, you get x plus 3 times x minus 3 is greater than or equal to 0. Once again, we do our little number line trick. Looks like which x values make this thing go to 0. Looks like if you plug in +3 or -3, this is going to be equal to 0, right? If you plug in -3 into this x, this whole thing is going to be equal to 0. 0 times whatever this is 0. And if you plug in +3 here, 3 minus 3 is 0, and 0 times whatever this is just going to be 0. Do our old number line trick. After we shade in the points, we do closed circles because it has the equal to sign at the bottom. Now we test out the numbers. So numbers in this range, let's say we pick 4. 4 plus 3 is 7. 4 minus 3 is 1. 7 times 1 is greater than 0, meaning that numbers in this range work. Let's pick out a number in this range. Let's say 0. 0 plus 3, 0, 0 plus 3, and then we have 0 minus 3. 3 times negative 3 is negative 9, and negative 9 is not greater than 0, meaning numbers in this range do not work. And then let's look at numbers that are less than negative 3. Let's say negative 4. Negative 4 plus 3 is negative 1. Negative 1 times negative 7 is positive 7. Positive 7 is greater than 0, which means that numbers in this range do work. Looks like numbers that are greater than or equal to 3 and numbers that are less than or equal to negative 3 are our answer. Let's do number 44 now. X plus 2 times x minus 1 times x minus 3 is less than or equal to 0. Now, good thing is that they moved everything already to one side, and they already factored everything for us. So what values of x make this equal to 0? Well, positive 3, right? If you plug in a 3 here, you get 0, and 0 times whatever these two are is going to be 0. Looks like positive 1 and negative 2. So now you notice this is really weird because now our number line is divided into 4 sections in this case. So now we have to test everything in these 4 sections and see if it works. So let's go through each section one by one. Let's look at x values that are less than negative 2. And by the way, once again, we also use closed circles for this because we have the equal to sign at the bottom. So once again, closed circles for all of our critical points. And let's begin. So let's say if I plug in negative 3. Well, negative 3 plus 2 is going to be a negative number, right? Negative 3 minus 1 is going to be a negative number. And negative 3 minus 3 is going to be a negative number. Now, when we have 3 negative numbers multiplied together, right? We multiply 3 negative numbers together. Well, this cancels out to be positive, right? This negative cancels out to be positive, and we just end up with a single negative number. And obviously, a single negative number is less than 0, which means that numbers in this range work. If you're confused by what I said, you can actually just plug in negative 3 actually into the thing and it'll work, right? For example, this would be negative 1, this will be times negative 4, this will be times negative 6. This negative cancels out, and we just get 4 times negative 6, which is negative 24. So sometimes you don't actually have to plug the number into the number line. Sometimes you don't have to plug the number into the inequality. Sometimes you just have to check the signs of when you plug the number in. And then if it comes out like negative or positive, because the other side is equal to 0, it's very easy to tell if it's going to be greater than or equal to 0. Sorry, I'm yapping a lot here. Let's test out the second section. So a number in between negative 2 and 1 is 0. Let's plug 0 into all of this. We get 2 times negative 1 times negative 3. Negative makes a positive, and we end up with a positive number, which is 6. Meaning that 6 is not less than or equal to 0, meaning that this section does not work. Number in between 1 and 3 is 2. Let's plug in 2 here. 2 plus 2 is 4. 2 minus 1 is 1. 2 minus 3 is negative 1. When we multiply all of these together, we end up with a negative number. And the negative number is less than 0, meaning that numbers in between this range work. What about numbers that are greater than 3? Let's say if I plug in 4. 4 plus 2 is 6. 4 minus 1 is 3. 4 minus 3 is 1. Multiply all of these out together, I get a positive number, which is not less than 0. So numbers in this range do not work. Looks like our answer is anything that's less than or equal to negative 2, right? And it also looks like any x value that's greater than or equal to 1 and less than or equal to 3 also is part of our answer. Alright, here's where it gets a little bit tricky. Let's do problem 48 first. And once again, it's the same thing. We want to find x values that satisfy this inequality, that make this inequality true. It's the same thing from what we did before. So in this case, Now what we're dealing with is we are dealing with fractions. So how do we do this? First thing, remember, every kind of step we got to do is, first step we got to do is we got to move everything to one side, right? So that the other side's equal to 0. Once again, they are nice enough to bless us with this easier inequality. Because we are dealing with a fraction, once again, we are going to do the number line method. We're going to find values that make the numerator equal to 0, and we are going to find values that are going to make the denominator equal to 0. So it's a little bit different from the strategy we used the other questions. Find values that make the numerator equal to 0. Well, what value makes this numerator equal to 0? So what value of x makes 2x plus 6 equal to 0? It's minus 6 from both sides, divided by 2. We get that when x is equal to negative 3, our numerator is equal to 0. And once again, we do the same thing for the denominator. We set the denominator equal to 0. We want to find out what x value makes this equal to 0. And obviously, when x is equal to 2, the denominator is equal to 0, which means that we are going to put this here. So once again, 3 sections on our number line, and we do the same thing as we did before. It's important to note that the number that makes the denominator equal to 0, in this case, the number that makes this equal to 0 is 2. Well, you're always going to put an open circle above it. This is because, well, our denominator can never be equal to 0. Otherwise, this is undefined. So we are never going to include 2 as our answer to our inequality. We are always going to have an open circle on top of it. And for this negative 3 right over here, we don't have the equals to sign, meaning that we also put an open circle. All right. So if this was an equals to sign, less than or equal to sign, we would shade in this circle, but we would keep the thing that makes the denominator equal to 0. We would not shade this circle in, right? Because this cannot be our solution, right? We're never going to include this. But because this is only a less than sign, we do not shade in the circle. 3 sections, you know the drill. Let's say if we pick number 3, right? A number that's greater than 2. So we have 2 times 3 is 6, 6 plus 6 is 12, and then 3 minus 2 is 1. And 12 over 1 is not less than 0, meaning numbers here do not work. What about numbers in between negative 3 and 2? Let's say we pick 0. So we have 6 divided by negative 2, which is negative 3, and negative 3 is less than 0. So numbers in this range work. And what about numbers below negative 3? Well, let's say we pick negative 4. Negative 4 times 2 is negative 8 plus 6 is negative 2. Negative 4 minus 2 is negative 6. Negative negative makes a positive. So this positive number is obviously not going to be less than 0, meaning that numbers in this range do not work. So our answer is x values that are greater than negative 3, but less than 2. That's going to be our answer. Let's do the next problem. So we have number 52. 3 plus x divided by 3 minus x is greater than or equal to positive 1. I'm going to do this in a different color. So the first thing you want to do is, once again, you want to move everything to one side. So once again, I'm just going to subtract 1 from both sides so that we have 3 plus x divided by 3 minus x minus 1 is greater than or equal to 0. Now this is a tricky part. The thing is, we want to combine these two terms together. But the problem is that we do not have a common denominator. So how can I make this 1, negative 1, have a common denominator with what I have here? Well, let's start by thinking of negative 1 not as negative 1. Instead, think about negative 1 as negative 1 over 1, right? So now we actually have the denominator. And what I'm going to do right now is I'm going to multiply the top and the bottom of this thing by 3 minus x. Notice how I multiply the top and the bottom, meaning that my inequality remains true, right? My inequality remains equal the whole time. All I'm doing is kind of altering this expression a little bit, this inequality a little bit, but I'm not changing the value of it. That's really important. whatever you do to the top, you got to do to the bottom. And the reason I multiply the top and the bottom by this denominator is that now I have a common denominator, right? Now both of our denominators is 3 minus x. So once again, we are going to simplify this a little bit. We have 3 plus x divided by 3 minus x minus, and then in parentheses, I'll just put 3 minus x divided by 3 minus x. If I distribute this negative sign, I get 3 plus x minus 3 plus x divided by 3 minus x. And in this case, this positive 3, this negative 3 cancels out, and I get that 2x divided by 3 minus x is greater than or equal to 0. Greater than or equal to 0. But kind of all we did here is we get a common denominator, we simplify everything. You'll notice how, because it's like when you have 1/3 plus 2/3, right? If you have a common denominator on a fraction, you can combine the fraction into 2 plus 1/3, right? That's exactly what we did last step. In one of the steps, what we did was, well, because these two terms had a common denominator, what we did was we combined the fractions together into this one bigger fraction. Therefore, we can actually simplify all of the terms there. And we're left with 2x is greater than or equal to 0. Now it's pretty clear what values, so now it's time to ask yourself, what values make the numerator equal to 0? And what values make the denominator equal to 0? And we're going to put this in our number line. Obviously, the value that makes the numerator 0 is just 0. And then the value that makes the denominator 0 is 3, right? Sorry. 3, and then we have 0, right? If we plug in 3 in for x in the denominator, this denominator is going to be 0. Remember, whatever value that makes the denominator equal to 0, no matter what, always put an open circle in. And then for the numerator, you just follow the same rule as before. You check the sign to see if it includes the equal to sign. And if it does, you shade in the circle. If it's just greater than or less than without the equals to sign, you have an open circle. In this case, with this equal to sign, we shade in the circle. 3 sections, you know the drill. So if I plug in the number greater than 3, let's say I plug in 4. I have 2 times 4, which is 8. 3 minus 4 is -1. This is not greater than 0. So numbers there do not work. What about numbers in between 0 and 3? Say I plug in 1. 2 times 1 is 2. 3 minus 1 is 2. This is greater than 0, meaning numbers in between this work. Finally, what about numbers that are less than 0? Well, let's see. So let's say if I plug in -1. 2 times -1 is -2. And 3 minus -1 is just 3 plus 1, because negative makes positive, which is 4. And this is clearly not greater than 0, meaning that this is not part of our solution. So our final answer is that anything that's greater than or equal to 0, but less than 3, works as our answer. So final 2 problems, but before we do them, you got to know an important formula. So let's say if we want to find out the absolute value of x is greater than 4, and we want to find out what values of x make this inequality true. Well, the first thing, the absolute value of a number just indicates the distance the number is from 0. For example, the absolute value of -4 would be just +4, because -4 is 4 distance away from 0. So if you want a number that's greater than, the absolute value of a number that's greater than 4, well, x has to be greater than 4, or you can have x being less than -4, right? Any number that's less than -4, let's say if you plug in -6, well, that's just the absolute value of -6 is just gonna be +6, which is greater than 4. And obviously, if you just plug in a number that's greater than 4 in here, well, it's gonna be the same number, right? When it's plugged into the absolute values thing. So this kind of concludes our formula. When you're solving these absolute value equations, let's say we have absolute value of x is, let's say, greater than y. What do we do to solve this? Well, imagine we can break this up into two equations. So imagine if you have the same inequality, except you remove the absolute value sign. That's one inequality that can be split up into. And then the second inequality, what you do is you remove the absolute value symbol, you change the sign, so you flip the sign, and you negate the other side. So I'm gonna do two inequalities, practice kind of inequalities with absolute value signs to get you used to this formula. So let's say if I have an absolute value of x plus 1, and let's say it's greater than 1. What two equations can I separate this into? Well, it's either the absolute, well, the first thing I can do is imagine this equation, this inequality, except it did not have the absolute value sign. That's one of the equations I can split this up into, right? It's just the original equation, except nothing has changed except for the absolute value sign. So just remove it. And in the second equation, what you do is you remove the absolute value sign, you flip the sign, and then you negate the other side. So these are the two equations I can split this up into. Let's do one more example. Let's say if I have the absolute value of x plus 1, and then let's say it's less than or equal to negative 1 plus x. What are the two inequalities I can split this up into? Well, one thing I can do is I can just rewrite this entire equation, except I've removed the absolute value sign, right? And then in the second equation, what I do is I've removed the absolute value sign. So actually, I'll make this arrow longer. So I'll remove the absolute value sign in the second equation. I flip the sign, and I negate the other side. So I multiply everything in the other side by negative 1. So if I multiply everything here by negative 1, right, I get negative 1 times negative 1 is positive 1, and then negative 1 times x is just negative x. So that's just a hang of doing this absolute value formula. Let's start by doing problem 75. So we have 8 minus absolute value of 2x minus 1 is greater than or equal to 6. Once again, this problem is actually, when you're doing these absolute value inequalities, you do not want to move everything to one side, okay? This is going to be different. What you want to do is you want to kind of isolate this absolute value sign. So it's kind of like, solving, like, let's say x plus 8 is equal to 6, right? You isolate the variable, right? Isolate it. So how can you isolate this absolute value sign? Well, first of all, I can subtract 8 from both sides. I get negative absolute value of 2x minus 1 is going to be greater than or equal to negative 2. And then finally, to isolate this absolute value sign, I can divide everything by negative 1, right? And what this does is this cancels out. So I get just the absolute value of 2x minus 1. Remember, when you're multiplying or dividing by a negative number, you flip the sign. So this is going to be less than or equal to positive 2. Now we can do our strategy, right? Now that we isolated our absolute value sign, we can do the formula that I've shown you, right? We can do two equations, two inequalities. First inequality is just the same inequality as I have up here, except it's without the absolute value sign. And in the second inequality, what I do is I remove the absolute value sign, I change the sign, and I negate the other side. Solving for x. So now that I have these two inequalities, how do I solve for x? Well, first, in the first inequality, I'll just add 1 to both sides. This is just going to be equal to 3. And then I just divide by 2. So my final, the answer for this inequality is x is less than or equal to 3 over 2. Sorry if this thing is a little bit hard to see. And then in my second inequality, I'm going to get 2x is greater than or equal to negative 1, right? I just added 1 to both sides, divide by 2, and then I get x is greater than or equal to negative 1/2. So now that we have our two answers, let's plot this on our number line. So yeah, you always notice how the absolute value, when you're doing absolute value inequalities, the strategy is so much different from doing the other ones, right? In this case, we don't plot it out first. We solve it. We solve for the values first, and then we plot it. It's really weird. So we have x is less than 3 over 2. X is less than 3 over 2. And then x is greater than or equal to negative 1/2. So x is less than 3 over 2, greater than... Alright, so it looks like just numbers in this range, right? Just looks like numbers in this range work. Final problem. So once again, what we do is we try to isolate this absolute value sign. We subtract 5 from both sides. So we get 7 absolute value. 7 times the absolute value of x plus 2 is greater than negative 1. Now, we could already stop right now and take a look at what's happened. You have 7, which is a positive number, multiplied by the absolute value of x plus 2. Now, the absolute value of anything is going to be a positive value. For example, the absolute value of negative 100 is always going to be positive, right? It's just 100. So you have a positive value, which is 7, times another positive value, which is this absolute value, the x plus 2 inside the absolute value sign. So the answer to this problem is that it's actually a trick problem. The answer to this is actually all real numbers. It doesn't matter what value of x you put into this inequality. So for example, if you put, let's say, negative 100 in, negative 100 plus 2 is negative 98. The absolute value of this is 98, positive 98. So you have a positive number times a positive number, which is always going to be greater than a negative number. So yeah, you could just stop and look at the problem right now. And logically speaking, like, this kind of makes sense, right? Because, just can't be a negative number if you have two of them that's positive multiplied together.